Hello everyone, welcome to the communication lab. The aim of the experiment is simulation of delta modulation using Matlab. In delta modulation, the sampled message is being modulated into a single bit. Here, the difference of the adjacent sampled signal is encoded in one bit, either 1 or 0. So we have a comparator to compare the message and the integrated output. If SH is more than the RT, the D flip-flop produces 1, else 0. It could be better understood by a waveform in the next slide. Here MT is the baseband signal, RT is the staircase approximated signal, the quantized signal, delta is the step size, and D is the modulated output, the sequence of bits generated. So let's go to the Matlab code and see how to get a baseband signal, the quantized signal, and the delta modulated sequence. Here is the Matlab code where time is taken from 0 to 2 pi. With the interval of 1/100th of the 2 pi. M is the baseband signal, 5 sin omega t. Next command is plot M, and next is the hold on. Hold on is used to plot another signal in the same graph. Y is the matrix, the variable used for storing the bits, the sequence of bits. And R is taken as initial value to be 0, the staircase approximate signal. The integrated output signal is taken as 0 initially. Delta, the step size, is taken as 0.4. It has to be carefully chosen. If it is too small, it results in slope overload error or the noise. If it is too high, say around 2, 3, 4, it becomes the noise becomes granular type. The loop has been taken for comparator. So if the message is more than the integrated output, D becomes 1, the modulated output becomes 1, else it is 0. Y is equal to YD, where Y is the variable and it's a matrix, and here we are storing the sequence. Stairs R is a command used to plot or show the staircase approximated signal. Hold off means we end the, no more graphs are being plotted in the same, and Y is the output. If we look at the figure generated over here is like this, in which the continuous line is a baseband signal. The staircase is the quantized output, the staircase approximated signal, or the integrated output signal. The sequence of bits generated at the output of the modulator is shown here. Y is 0, 1, 0, 1, 1, 1, 1, 1, 1. Each bit is being specified for a particular sampled message signal. If we wish to display the sequence of bits in the form of waveform, then we can use the command stairs y and the stairs y to display the waveform. So I have used axis. This from 0 to 100 is the x-axis, and -2 is y, and 3 is the y, y1 and y2. So to have a clear view of the waveform, I have taken the axis, and if we see the plot of these bits, we get a waveform like this. This is the sequence of bits displayed in the form of a rectangular pulse. So if you just have a look initially, we have 0, 1, 0, and then 1, 1, 1 is still over here. So if I wish to see this in this figure, I have 0, 1, 0 again, and 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 such 1 bits. Then again I am getting 0 here, and 1, 1, and then 0. So I have 0, 1, 1, 0 again, 1, 1, then alternately 0, 1, 0, 1 I am getting. So here alternately I am getting 0, 1, 0, 1. So thus these bits, they resemble this waveform, and over here this is the 0 bit around this so many bits of zeros are here that has been displayed and in this figure over here, over this region. Thus this represents the delta modulated output. We end this program. Thank you.